All right, our last topic in chapter 1 is inverses. So when you do the inverse of a function, so back in Algebra 1, you learned how to do the inverse of something. Now, when you have a set of points, it's called a relation. So, and to be a function, remember that your x values cannot repeat because you have to have passed something called the vertical line test to be a function. So these x values do not repeat. So basically what happens is that every x value can only have one y value. Well, if your x values don't repeat, then there's no chance of anything bad happening. So like, for instance, if I had another point on here, then it was like -2, 7. So if I added that extra point, then look what happens. -2 is going to 4 and -2 is going to 7. One input cannot go to two different outputs. That's not a function, because a function means one input, one output, that's it. Okay? So anyway, this one is a function. I made it that way. So the inverse of this would be when I switch the numbers, right? So an inverse is when you take x and y and you reverse them. So the inverse of 1, 6 would be 6, 1. The inverse of -2, 4 would be 4, -2. So that's all you're doing if you have a point. And then it'd be 6, 3, and then 8, 4. So those are inverse. That's an inverse. Now, look at this inverse. Is it a function? So here's my x values. Look right here and right here. 6 goes to 1, and then 6 goes to 3. How can that be? Like, you can't just sit there and, say that one input gives you two different outputs, okay? Like, you can't ask your mom and dad the same question and expect two different answers, right? Like, they might, but, you're not supposed to, okay? All right, so is this inverse a function? No. All right, so remember, there's a thing called the vertical line test that you learned in Algebra 1. It tells you if something is a function. So if you go and test it, so you draw vertical lines. If I draw a vertical line through that point, it only hits one thing, one thing, one thing, one thing, one thing. All right, this graph over here, if I draw vertical lines through it, it only crosses, each vertical line only touches the graph once. Now, something that wouldn't be a function, like let's say that we had a parabola on its side like this. And if I drew vertical lines through this, now right here it would hit one time, but any place else, see how it hits twice? So that's not a function, okay? So a lot of things that we deal with are functions. Every once in a while you get something that's not a function. Let's say you had like a circle, all right? On the edge it's fine because it only hits one time, but any place else, bad. The edge is fine, but it fails the vertical line test. Okay, all right, so we are going to do the inverse of this function here. So let me make this kind of big. All right, so let's see, -5, -5. Well, -5, -5 would stay in the same place when I switched it. Let's see, -2, 3. So this point right here, -2, 3, would be 3, -2. So right there. All right. This guy up here, 0, 4, is going to be 4, 0. Down on the bottom right, 3, -4 would be -4, 3. And the last one on the right, 5, 1, would be 1, 5. All right, so if you turn your head kind of sideways here, if I draw a line right down the diagonal right here, that is the line y equals x, all right? It's y equals x because remember the equation of a line is y equals mx plus b. It goes right through 0, so this is 0. The slope is up 1 over 1, so this is a 1. So it's y equals 1x plus 0, so that's why we shorten it to y equals x. That line, that line right there cuts this graph in half. So notice how this purple point and that green point are across that line from each other. This green point and that purple, they're like the reflected over that line, okay? These 2 points, if you fold your paper this to there, like it reflects. So inverses are symmetrical over this line. This line cuts them in half. Just like, if you had a face, if you put a line down the middle, your face is going to be the same on either side, right? So you're symmetrical right down the middle of your nose line, right? So they're symmetrical. Inverses are symmetrical over the line y equals x. All right, so let's take a look at this guy. So if I want to do the inverse of this, I'd like to pick out some good points. So some good points on this graph might be like 2, 0, looks like 3, 1, maybe 6, 2. Okay. All right, so the inverse, let's take a look. 2, 0 would be 0, 2. 3, 1 would be 1, 3. And 6, 2 would be 2, 6. So I can tell that that thing curves on up this way. All right, and then just do one last check. Let's draw that line, y equals x down the middle. And yeah, look, they're symmetrical. Like they basically fold over that line and they become the same thing on the other side. All right, so let's do one more thing and look at how domain and range are affected with inverses and so forth. All right, so the original graph. The original graph right here, this green one, the domain, it basically exists from 2 to the right. So the domain is from 2 to infinity. The range, this graph, is from here up, right? So it's from 0 up, 0 to infinity. So 0 to infinity. So let's look at the inverse, the blue one. So the blue one, the domain, it goes from here over. So that's from 0 over. So 0 to infinity. And the range goes from here up. So from 2 on up. So that's a fact about functions and their inverses. Look, the domain switches to the range, and the range switches to the domain. Because what was your x's and your y's, since you're switching them, they're reversing, right? You're switching the x's and the y's, so it makes sense the domain and range switch places. All right, one last thing you have to know how to do, and you'll have to know how to do this later with more difficult functions, but for right now, this is a line. This is the line y equals 2x minus 4. So there's a special notation for inverse, and that is this. If somebody gives you h of x, that's the original. And if somebody wants the inverse of something, you put a little -1 power, and you put an x. This means the inverse. So we're going to find the inverse of this function. Let's graph it first. 2x minus 4 would be here. All right, so let's find the inverse. So when you're finding the inverse of a equation, what you do is, you make it y equals instead of h of x or whatever, just to have x and y, and you switch the y and the x. So my first step, I switch x and y. So you don't move anything else. So this y here becomes x, and then 2y minus 4. And then the next thing I have to do is I have to resolve it for y, so I can graph it again, so I can take a look at it. All right, so I'm going to solve this for y. I have to basically move this 4 over. So I'm going to write 2y equals x plus 4, just to have it in the right format. Then I got to divide every single part by 2. So y equals, this becomes 1/2 x plus 2. So there is my inverse. Now, that's the inverse when this was the original. But to write it properly, since my problem said h of x, I am going to write that the inverse is h-1 of x equals 1/2 x plus 2. So that would be how I should truly write my answer, right? Because that means inverse, h-1 of x. So let's graph it over here and see what it looks like. So it starts at 2, and it goes up 1 over 2, up 1 over 2. All right, and then we'll take a look at some points. All right, so let's take a look. Let's see, 0, 2, 2, 0, good. -4, 0, 0, -4, good. 2, 3, well, look here, 3, 2. Okay, perfect. And if I go ahead and draw my y equals x line, seems to cut that space right in half. Now you don't have to draw that line, I'm just showing you. All right, and that is it.